Hello, this is question 12 on your AQA sample 3 paper, so the A-level paper. During the 2006 Christmas holiday, John, a math teacher, realized that he had fallen ill during 65% of the Christmas holidays since he had started teaching. In January 2007, he increased his weekly exercise to try to improve his health. For the next 7 years, he only fell ill during 2 Christmas holidays. Using a binomial distribution, investigate at 5% significant level whether there is evidence that he has decreased the rate of illness. So we are going to write, as always, the hypothesis. So H0 is going to be probability of falling ill is still 0.65. And the probability, the alternative hypothesis is going to be smaller than, because we are checking if the probability of falling ill has decreased. So this is going to be smaller than 0.65. Significant level is 5%. We check 7 years. So he checked 7 years and he fell ill 2 of them. Yeah, so X is 2. We are going to assume that this one is true, which means we have a binomial 7 and the probability is 0.65. So to check if this is true or not true, what we're going to do is to see what's the probability of the observed value. So if he falls ill twice, so we are going to check what's the probability of X being smaller than or equal than 2. Yeah, if we are checking the lower values, we have smaller or equal. If we are checking the other side, we have greater or equal. And we are going to compare this with the significant level. If you use binomial CD in the calculator with this X, N, and P, we get 0.0556, which is slightly greater than the significant level, which is 0.05. So if it's greater, that means that this is still quite likely or likely enough to happen if this is true. So we are going to assume that this is true. Yeah, we are going to accept H0. We don't have enough evidence to reject it. Accept H0. We have to write something. There is not enough evidence. Evidence to reject. Or to support the claim, if you want. To support the claim that he has fallen ill less. No? To support the teacher's claim. He was assuming that the probability of falling ill has decreased. Yeah. So that's this part. If you prefer, instead of doing this way, so finding the probability of the observed value and comparing with the significant level, finding the critical region, you can do that way as well. So to find the critical region, you need a value A, such as the probability of X being smaller or equal than A is 0.0, it's smaller than 0.05. This binomial is not on the tables in your formula booklet. Yeah, 0.65 is not one of the probabilities that you have. So you have to do it with a calculator. You can just try values of X until you get the first one that is smaller than 0.05. So if you know that 2 is 0.056, which is slightly above, we are going to try the next one. The next one is 1. And when X is 1, this probability is 0.009, which is already smaller than the significant level. So this is going to be our critical value. Yeah, so the critical region is going to be X smaller or equal than 1, sorry. So he needs to fall ill once or less to decide that this is true. Yeah, and he falls ill twice, so 2 is not in the critical region. It's not in critical region, therefore we have to accept H0, and there is not enough evidence and all that. So we write the same line, yeah, because it's just an alternative method if you prefer to find the critical region or if they ask you to find the critical region. It's not that you need to do both. And then next part, it says, state 2 assumptions regarding illness during the Christmas holidays that are necessary for the distribution you have used in part A to be valid. And for each assumption, we have to comment in context whether or not it's likely to be correct. So remember that we assume 4 things for the binomial distribution. One is that the number of trials is constant or fixed. So I'm just going to make a note of that. So fixed number of trials. We have constant probability. We have 2 outcomes. And they are independent. So each trial is independent from each other. So you can pick two of these either, and then comment if that could be possible. So for example, I would say the probability should be constant. So the probability of falling ill should be constant. But I would say that's not very likely. So about the probability constant. Because the probability of falling ill depends on many things. Also, the immune system changes all the time. Constant, I would say not very likely. Immune system change all the time. So it's not just the exercise, it will be the diet, it will be stress, or other things. Yeah. So immune system change with time. Diet, stress, etc. Yeah. So this is not very likely. The other one that we could mention, for example, I would say that they are independent. The trials are independent. That would mean the GRs are independent. I would say this one is more likely because what happens in one Christmas holidays, it doesn't affect probably what happens in the next Christmas holidays. They are just quite far away. Yeah. So what happens, something like this. What happens in one Christmas holidays regarding to health, yeah, so health won't affect next Christmas holidays. Something similar to this, yeah. And that's all with this question. That's remember, you have to give reasons. You say for each assumption, comment in context whether it's likely to be correct. Yeah, don't overthink it. It's just a bit of common sense. Yeah, and that's all with this question.